Hello, algebra students. This is a lecture on section 7.3, where we are going to start talking about what happens when our exponents are negative or when our exponents are zero. We're still talking about the same properties that we were talking about from the previous lectures, only now including negative or zero exponents. There are really two things that you're going to need to know to be able to accomplish this lesson. The first one is that anything to the power of zero is 1. Okay, if you ever are taking something to the exponent of 0, the answer is going to be 1. That seems weird or not really what you would expect, because I would think, and I would think that you would think, that if you took something to the 0th power, the answer would be 0. But in actuality, anything to the 0 power is 1. The other thing that you need to know is that anytime you have a negative exponent, to fix that, because your answer can never have a negative exponent. If you are taking a quiz or a test or something and you look and you see that you have a negative exponent, I'm telling you that it's wrong. Okay? The exception will be when we talk about scientific notation in a future lecture, but as of right now, if you're just simplifying exponents, you should never have an answer with a negative exponent. Basically, you're going to need to fix negative exponents, and the way to do that is to move its base to the opposite location. And when I talk about location, I'm either talking about the numerator or the denominator. Any number has a numerator and a denominator, right? Even if it was like 2, I could make 2 into a fraction, 2 over 1, right? So here would be my numerator, and here would be my denominator. So 2 is in the numerator if I'm just talking about the number 2, okay? So you're going to move its base to the opposite location. If it's in the numerator, you're going to move the base to the denominator. If it's negative exponent in the denominator, you're going to move the base to the numerator and then make the exponent positive. I'll just show you an example. If I have 1/3 and the 3 in the denominator is being taken to the negative second power, I'm going to move that to the numerator. So then it would be 1 times 3 to the second power. You move it to the numerator and then make the exponent positive. We know 3 to the second power is 9, and 1 times 9 would just be 9. So 1 divided by 3 to the negative second is just 9. All other properties will still apply with negative exponents. I'll show you what I mean by that in a little bit, but all the properties that we learned from the first two sections still apply even if you have a negative exponent. But that big key is you can never have a negative exponent in your final answer. Let's look at some examples here. This is just really similar to the last example I showed you. I have 1 divided by 4 to the negative third power. Remember, you're never allowed to have a negative exponent. And so anything with a negative exponent just gets moved to the opposite location. So this 1 does not have a negative exponent. It'll stay there. So it'll be 1 times 4 to the third power. Well, I know what 4 to the third power is. I can figure it out on my calculator. That's 64. And 1 times 64 would just be 64. That would be my answer here. You should be able to type this in your calculator and verify, and it should work out. It should be 64. So remember, if there isn't a fraction, you can make it a fraction by putting it over 1. And this has a negative exponent right now, and it's in the numerator, so it's going to need to go to the denominator. So then this would be 1 times 0 to the positive second. When you move something to the opposite location, then you make the exponent positive. Once I moved that to the denominator, there was nothing in the numerator. So if there's nothing there, you can just put a 1 there, just like we put a 1 down here. We should know what 0 to the second power is. If you said 1, I understand what you're thinking, but that's not the case. Something to the 0th power is 1. But if you have 0 to a power, you can type that into your calculator. 0 to the second power is 0. 0 times 0 is 0, is it not? So here we'd have 1 divided by, and 1 times 0 is 0. What is 1 divided by 0? Hopefully, you are saying no solution. We get a divide by 0 error here. I would accept no solution or undefined, is I guess what I would accept. And I already did this one as I was talking about this problem here. Anything to the 0th power is 1. Negative 2 to the 0th power, 1. 4 to the 0th power, 1. Okay, 100 to the 0th power, 1. Should be an easy one in your test. In the first slide, I talked about how all rules from the last two sections still apply. There's a couple different ways to answer this question, and that's going to be the case for most of the problems that we do. Some of you guys might have thought, hey, when I divide with the same base, I can subtract their exponents. So you would still have 4 as your base, but you would take those exponents and you would subtract them. And so you do 4 subtract a negative 3. And 4 subtract a negative 3 is, of course, 7. And so 4 to the 4th divided by 4 to the negative 3rd is actually 4 to the 7th power. That's one of the ways that you could have thought about this. That would have been using the properties from the previous two sections, right? The one that says when you divide, you subtract their exponents. However, using the new properties from today, you'd be like, hey, I'm not allowed to have a negative exponent. And so you would move this base to the numerator. So it'd be 4 to the 4th. And then this would get moved to the numerator times 4. Remember, when you move something to the opposite location, you make the exponent positive. So then you'd have 4 to the 3rd. Now, once again, think back to previous sections. When you have two things that are being multiplied with the same base, you would add their exponents. And what do you get? 4 to the 7th. So we got the same thing both times. We just used different methods to get there. And that's going to be the case. You're going to just make sure you're using your properties. But as long as you're using your properties, you should be fine. Let's look at a couple more examples. And like I said, I might be thinking of these in a different capacity, in a different order than you might be, and that's just okay. So some of you guys might have said, hey, this has a negative exponent, so I'm going to move it down to the denominator if it makes the exponent positive. That would be totally fine. There would be nothing up here in the numerator anymore, so it would just be a 1. And then in your denominator, you'd have this 6 to the 2nd power. And you'd have this 6 to the, when you move it, it would also be 6 to the 2nd power. Now they have the same base and they're being multiplied. So you'd add their exponents, 1 over 6 to the 4th. Okay? There's other ways that you could have done this as well. You could have right away subtracted their exponents. That would have given you 6 to the, if you do negative 2 minus 2, negative 4th. And then 6 to the negative 4th, when you fix the negative, it would be 1 over 6 to the 4th. You would get the same answer. Let's try another one. We have this negative 2nd power on the outside. Remember, if you have a power on the outside of parentheses, you can apply that to everything, kind of like the distributive property. So when you do that, negative 4 would need to be in parentheses. Remember, if you have a number with a negative in front of it being taken to a power, it needs parentheses around it. So negative 4 to the negative 2nd times x to the negative 2nd times y to the, remember, if you have something being taken to a power, being taken to another power, you multiply their exponents. We definitely have some issues here. We have some things with negative exponents. So those are going to need to be moved down to the denominator because we're not allowed to have those negative exponents. We need to fix them. This y to the 4th is going to stay up in the numerator because it's got a positive exponent. So it'll be y to the 4th over negative 4 to the 2nd, x to the 2nd. Depending on the phrasing of the question, this might be the answer, or if it said simplify your exponents completely, it would be y to the 4th over 16 x to the 2nd. If you type this into your calculator, negative 4 with parentheses around it to the 2nd power, that would be 16. Let's just do one more of these, and then we'll be done for this lesson. Very similar to this one, we're going to take that exponent. It would be a great time to pause here, see if you're able to get it. Take that exponent, apply it to everything. It would be 2 to the 3rd, x to the 3rd, y to the negative 15th. Anything with a negative exponent does need to get fixed or moved. So this guy here is going to go down to the denominator. 2 to the third, x to the third over y to the 15th. Now, recall, this might be the answer. Or if I said simplify your exponents completely, 2 to the third is 8. So your answer would be 8 to the third, x to the third over y to the 15th. Sorry, not 8 to the third. 8. Let me know if you guys have any questions. Otherwise, that's all I got for you guys today.